Digital effects. I think a real generic way of explaining it is most people consider anything that involves a computer. And there's really two distinct fields. One is compositing. The other aspect of computer work is CGI, computer-generated imagery. The difference between the two is compositing, again, you're putting the elements together, and CGI, you're actually generating elements. The same way if you were shooting an element, you're actually creating something that didn't exist before.
A wireframe is our representation of a solid object. And how you get there basically are points in space, and that can be done either by an animator taking a point in space and saying this is connecting the dots basically and creating something that has a mass and has a solid volume to it. Once we've created the wireframe, then we have to have a certain point of view on that wireframe, and that changes for every shot. The beauty of the wireframe is once it's built, we can use it for any shot. You can put the F-18 flying straight towards you, and we in the computer have what's basically a virtual camera, and you can put the camera in the front of this 3D object and it looks like it's flying towards you. If you want to go to the side, you can move it to the side and you get the wings and you can show the rotation, and just off of the 3D object and this virtual camera that's used in computer graphics. Texture mapping is the next step. Once you've got your wireframe, which is your 3D representation to connect the dots, you then need to take a real surface and basically paint it over top of this texture.
Usually computer-generated images look synthetic. Therefore, you want to get some dirt, some natural images in there. And the easiest thing is to actually take pictures of dust and dirt.
We photographed, like a real F-18 on a tarmac, and in every, down to every screw, and and texture mapped it on a wireframe. I think, we went a big step there. It looks really good.
On this show, we had several sets of challenges. One of the biggest ones was the dogfight scenes. We're animating hundreds of airplanes in the air at the same time. And to do that plane by plane is just a really painstaking process, takes a really long time, because you have to do not only each F-18 or each attacker, but then each attacker shoots the attacker firing, and each F-18 fires missiles and tracers, and there's hundreds and hundreds of objects to keep track of. And then even some of the objects that are like the F-18's missile fire, they emit fire and smoke as well, so you've got literally thousands of things to keep track of in the scene. Since we're doing this all with computers are really good at doing that, good at simulating all those things, so we've written programs which do nothing but simulate the dogfight scenes in a way that we have a lot of control over them.
You will see in this movie scenes where 150 F-18 American jets will be fighting over 250 alien attackers in the most spectacular aerial sequence ever filmed. Now, this wouldn't have been possible without digital technology, without computers.
The solution before we were brought onto the show was to hand animate all of this. So it's just as if you were to do it with motion control, do it with some traditional methods. You have to actually hand animate each F-18 or each attacker. And then they were doing things like copying some different paths and whatnot. But it was still basically a ton of hand animation. It would take several days to set up one shot and then render it, and then several days to do another shot. So we were able to take it from about a 4 or 5 day turnaround per dogfight and bring it down where we can basically produce 2 dogfights in one 24-hour period.
I've never seen CG, computer-generated imagery, come out as fast as on this show. I mean, Roland can call in and fax us over a storyboard at 9 o'clock at night and have an animatic and have animation by the next morning. And normally that would take a week to 2 weeks, on normal pace. Because there's a limited amount of horsepower in the computer, even though these are really fast computers, we have to use primitives, or these little dots, to represent each of the airplanes at first. You can see it's only stepping a few frames per second. It's only stepping very slowly through the dogfight, and that's so we can tweak each of the individual parameters as it's stepping through. And I can go through and adjust sliders or grab my equations and make adjustments to my equations in real time and see how that affects the dogfight. And then as soon as I get the motion the way I want it, as soon as I get the numbers the way that we want it for a particular shot, then I can go in and substitute the real airplanes for these dots. One shot alone, which is 21 CG planes, 2 motion control planes, and they're all firing 2 missiles except the president's plane, which is firing 1 missile. So all of that, and the shot just kept expanding and expanding. And eventually when we finally went to go back up the shot and get it laid off back to a backup format DST, we found out that the shot had totaled 52.5 gigabytes for that 1 6-second shot.